How about those White Sox, huh? Anyone White Sox fans? Like 4 in a row. I went Friday, big win. Showing the calendar there, just showing that we have 4 weeks. Let's finish strong. Okay, so now go ahead and write this down. We'll keep this between 0 and 360. We're going to extrapolate. And I'll tell you what 6'3 is all about on the next example. It's not this one. What did we all say we can expect for an angle measure there? Sine of what equals a half? 30. So everyone knows that. This is what I want you to see. And the first time of thinking this in this way, no one remembers the get triggy with it video. Nah, 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 nah. I started the whole trig in January. Don't shake your head back there. With that video. In that, they actually solve like, how come this is an angle measure? Whatever you do to one side, say it. Do the other. So to get rid of that sign, I want you to think about this now, especially for today. I inverse sign both sides. Oh, got real scratchy writing there, inserting that there. And then I want you to think about this more, especially with what's going to happen in the next example. Okay, so in a way, we're answering this question: x equals the inverse sine of a ratio. All right, and then we can continue. So that's not really a big deal. That's basic trigonometry. This is true. And then it's not only 30. Now you have to do your quadrants analysis. Where else is 30 wrong? Where else is sine positive? What quadrants? These better be coming fast. I'm being quite direct in quotations, jerky, because I don't care at this point. We should know ASTC. We should know all students means first, second. That's where sine's positive. This is a chapter 1 thing, actually. The ASTC thing we did in chapter 1. So 1 and then 2 and then 3. I'm sure we talked about it in 4 when we were graphing, and then definitely in 5. We've talked about it for 5 chapters at this point. So at this point, yes, we should know that there are 2 answers. I physically made the drawing of the triangle to connect it to how we first did this. Yes, of course, this third side is root 3 because it has to be. But the idea in the whole construction of the triangle, this is why the opposite side dictates the reference angle. So putting all these things together that I see is not going very well for some individuals. All right, but anyway, we know that those 2 answers then are 30 and 150. All right, so don't take this verbatim. This is review. All right, so just take this down real quick until we get to the new stuff. Be a note maker. Really pay attention to what I'm saying here so that we can make this fast. All right, now the next one. Okay, well, I told you this is review, so do have to get going with the notes here. But I guess we have the time, so I'll relax. White Sox playing today? Any Sox fans? Do you know? I don't know either. I don't know if they got a day off. Last week they played like one day. All right, we got to move on. Like I said, this is review. All right, I can't wait. All right, so here's the next one. This is what we want to write verbatim now. Oh, okay. All right, and then I say unfortunately. It's not unfortunate. Otherwise, we'd never learn something new if we didn't have a new thing. Unfortunately, this is what's going to happen to you today. That says sine of 2x equals. So 6-3 is double angle, triple angle, and then actually we're going to do half angle solving of equations. We're only going to approach it in one way, and then we're going to stop. Another way could be using identities from last chapter, depending on how the question is worded or depending on what type of question it is. So I still want you to understand that you are going to inverse sine both sides in your mind. This is not new. I could have done this all in chapter 6. Hey, whatever you do to one side, do to the other. This is why we end up with this. But here's the problem. When you inverse sine both sides, now 2x is free. The argument is 2x that I'm solving for. So problem number 1, how do I solve for 2x equals? What do I have to do to both sides to get x all by itself? Divide by 2. So there's going to be a divide by 2 component, which is not rocket science. This is not complicated. This is taking something one step further, baby steps. But there is something complicated about this, and it's the second part. This changes two things. We already talked about one of them. 2x equals, we're going to have to solve for 2x equals by dividing by 2. The next thing is all of these examples have this set of directions. I want all answers from 0 to 360. So just make sure you have that in the beginning of your notes for all of these examples. And now you're just going to have to memorize. And when I get to the worksheet, because I'm going to do a couple on the worksheet as examples, I'm just going to go fast with what is the way I solve. All right. How do I get this done real fast? And it really isn't that long. Okay, well, fine. 2x equals, you still have the same triangles. Okay, so inverse sine of a half still gives me those 230s. Don't write that again. Don't write that again. Just point up to the previous example. But here's number one, which everyone could probably figure out at this point. Not x equals 30 degrees. 2x equals 30 degrees. So what does that mean x equals for those two answers? One of them is 15 and 75. And those answers are true. Here's the problem. The amount of answers that work between 0 and 360 are actually doubled. That 2x doubles the amount of answers that work from 0 to 360. This is what you're going to do about it. You're going to take and come up with two more answers that actually work that are related to 30 and 150. And that is by simply adding 360. Isn't 390 in the same place as 30 degrees, correct? And isn't 360 plus 150 also a valid answer? It's just not between 0 and 360. So all you're going to do is add 360 once to each answer, and then that's also what 2x equals 2. And then you divide by 2, and that's where the 390 and 515 come from. But then you divide by 2. And then notice these other two answers, 195 and 255 as a final answer, actually fall between 0 and 360. So those are valid answers. So I see a hand up. Maybe you're going to answer your question if I climbed into your brain. If it's 2x equals, do I just add 360 to each answer and divide by 2? Yes. What if it's 3x equals? How many times do I have to add 360? Well, 2 more times to get 3 answers for every one. All right? And so on and so on and so forth. That's the how to. And then you'll see when you divide, all of the answers will end up being between 0 and 360. It's a true story. And I don't really think that's hard. It's different, but it's one thing to focus on today. And once you focus on it, it's actually easy when we get to Friday. All right, so I'll leave this up here for the note takers. Don't keep drawing those triangles. I'm just getting the point that when we get to this point, for this particular question, I got to do my cirkicks or ticks and figure out what angles I'm dealing with originally. And then I move on and say, okay, how many answers do I have? Add 360, and then divide by the number, whatever number is there. So I'm going to move on to 3x, sine of 3x. We'll actually emulate that. Really not too bad. So again, see what the backbone of it is. I still have people that still can't answer this question after all the things that we talked about, and that's where I can't help you at this point. I am done. Okay, all students take calculus, have to be at the top of your thing. You got to know cirkicks or ticks like the back of your hand. And then the triangles and the ratios that you're used to seeing that we've seen a million times. Oh, I know I'm not the most popular person with some people, but that's fine by me. I know what I'm doing here, and eventually you'll get there. And if you don't, then you don't. All right, so last but not least, you inverse sine both sides. You're not going to do this like a robot on every question. What I want you to understand why I'm doing this is you're freeing 3x now. So that's the argument that's free to solve for. So of course I'm going to have to divide by 3 to solve for x. But now when I analyze inverse sine of a half, well, in sine of what angle equals a half? The 30 is in 1 and 2. Sure, 3x equals those. Now, that's why you see my answers are 10 and 50 degrees. And actually, I haven't done this yet, but I could take those answers and plug them in and tell you why they work. It's actually very simple to do that. But then the amount of answers are tripled. So what do I do about that? I don't add 360 once, I add 360 twice. And then I take 150 and I add 360 once and I add 360 twice. So 390 is 360 plus 30. By the way, 390 is an answer that works. It's just not between 0 and 360. And then I add 360 again, and I get 750. Now, the only thing I really have to concentrate on is radians. What's the same thing as 360, though, guys? 2 pi. So then all we're going to have to do is incorporate fractions, which, again, I am a jerk about that. But, yeah, I've been trying to teach and tell you fractions are going to be important this whole year long. And those that are bad with fractions are going to struggle, bad with their grade school ideas. Because radians, that's all the only problem with radians is understanding how to deal with the fraction. Oh, that's what 3x equals as well. So going all the way to the end, 290 is 870 divided by 3. And 870 is adding 360 to 150 a couple more times. So really, that's what we need to concentrate on. That is what my math is going to look like. I'm going to go right to it. So step 1, what are the reference angles and what quadrants? What is the argument? Is it 2x? Then the answers are doubled. If it's 3x, tripled. 4x, quadrupled. And so on and so on and so forth. If it was a 4x, then I would add 360 3 times. For every one answer, I would need 4 answers that 4x is equal. And then divide by 4. Right? And that's the brass tacks of it. I do have one more extrapolation, though. If you had a fractional angle situation, which actually is nicer for you. Half angle, 1/3 of an angle could even be something that you do, and blah, 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 forever and ever and ever. Those kind of things. I'm just stalling for those writing this down. All right, now when I go to the worksheet for actual examples, it's going to be fast. I'm going to have my analysis. What do I have? What kind of angles and what quadrants? How many times do I have to double, triple, quadruple, and then divide? Done. All right, and that's pretty much it. Pretty much how it works. But we got some radian problems. And I don't know if I have enough work space on my worksheet that I created. I should have probably done it front and back, but I liked on the back having the answers that you could flip over and check without having to look at the internet. Are we good? Okay, now one more extrapolation about what if I have this? And I notice it's the same triangle, but when I inverse sine, I free x over 2 equals the inverse sine of whatever a half is, which is 30 and 150 again. This is 30 and 150, same thing. Well, what do I have to do to solve for x over 2? What do I have to do to both sides? Multiply by what? Sometimes this throws the second answer out and throws it past 360. So this doesn't add answers. You may get the same amount, or you may lose an answer because it goes outside of 360 according to the directions. All right, so that's what's weird about this one. Okay, so did I lose that half? I don't think so. Oh, there it is. So in order to do this, I don't add 360 because I think you're missing the whole point. You know, this is gonna throw answers past 360 possibly. So, and then here's my point of that. When I take 2 times both sides, I get 60. 2 times this 300. Okay, so it did stay between 0 and 360. The reason I did not add 360 is that would be 390 times 2. The directions say I want answers from 0 to 360. That's way out. So I don't do that. We're not going to answer all answers. That really isn't that hard either, but we're just not going to do it. We're going to either have all answers between 0 and 360 or all answers between 0 and 2 pi and leave it at that. So no adding 360 here because why would you? The answers go off far away, way past 360 when you have to multiply by 2 in order to solve. So again, feel pretty confident that this should be pretty doable. I feel that all year long, and then we'll see what happens. And I hope that sometimes the stars and planets align, and we have a 85% class average on a quiz or a test. So what we're hoping for, hope for it every day, or every 2 weeks when we have those quizzes. Really, you can count this week done. If you feel pretty confident with this, there pretty much isn't anything new. All righty then. So what did I mark as things that I wanted to do on this worksheet? Go to your worksheet, and then I'll show you how your work should kind of align out for this. Thank goodness. Finally, sick of half. Why did I do sine of x equals a half every single example? Because I wanted you to have a tie-in, how very similar questions, just the differences that happen with them. Now we can proceed on. I should be able to ask people questions, but you know what? You're here today, unlike half of the class, so we'll give you a break and just pay attention. But hey, class response, sine of what kind of angle gives me root 3 over 2 as a ratio? It's 60. So what you're doing, your very first thing that you do, and again, those that still cannot get this, I don't know what to do at this point. All right, this is Y and this is R. So you don't need to do that long convolution. I was doing that for long notes, long explanations to tie it back to chapter 2 in drawing triangles. At this point, we should know 1 root 3, 2, the side opposite root 3 is 60. And then what quadrant's we in? Can't get that wrong. 1 and what? 2. And for the love of dog, put at the top of this worksheet a big ASTC and keep looking at it and understand what it is. I'm working with people and they still don't know what this ASTC stands for. All right, so 1 and 2, that's what the S stands for, signs positive in quadrant 2. Probably should do this if you are on that level 2 of not having this down. The pen. And then I told you some other stuff you should write, like sine of a 30 equals a half, and then just that. Maybe sine and cosine of a 45 equals root 2 over 2, so you can recognize quick. So on and so on and so forth. But now this is what you got to do. And this is what I should see in your work. Maybe I'll go this way. So what's the 60 in 1? It's 60. That's easy. What's the 60 in 2? What's the 60 in quadrant 2? See, 120, and you heard someone say it out there. It's 180 minus 60 off of the nearest x-axis. Those are the two answers if it was just x equals. And that's what I want you to understand. So you'd be done if this was section 6.2, very beginning, easy questions. But it's not. It's 4x equals. So here's what you should do maybe across. Keep adding 360. 360 plus 60, 420. 420 is a valid answer for sine of x equals. It's just outside of 360. So I want you to also understand that. Oh boy, here we go. Mr. Samuelis's math skills. Add another 360, because for every answer, you want to write 4 answers. So is that 780? Can anyone verify that with me? And then add another 360. Why? Because the amount of answers is quadrupled. So every 60 degree in quadrant 1, I have to write 4 of them because you'll see what happens with the fourth one. 360, is that 1040? Oh, I never was good at math. See, I knew it. Just kidding. 360 plus 120, 480. Is that right? 360 plus another 480, 780, 840. Brain's hurting right now. And then 360 plus 840, is that 1200? And then you take all of these answers and divide them by 4 because that's what 4x equals. Wow, this is a crazy equation. 4x equals 4 different numbers with a comma on it. Actually, incorrect. 4x equals 8 different numbers. And then this is going to be kind of annoying, but isn't the first one 15? And then the next one is divided by 4, 120 divided by 4. Isn't that 30? 30, 60, 90, 120. Son of a nutcracker. What are the directions for this one? So good. I'm glad this happened. Wrong. We got to write all these over. Oh, no. Thanks, Logan. I didn't read my own directions. The first column is all radians. Yeah, there you go. I got you. You got me. You got me. Now, you know what? I'm definitely not dividing by 4. I'm multiplying by what? Ha, 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 ha. 1 over 4. Okay, by the way, what are the 60s? Over what? Over what? 3. So it's pi over 3. And then what's the one in quadrant 2? Should be simple. Did you say 2 pi over 3, I hope? Now, here's what you write off to the side. You should be able to do this. I have to add 360. Wrong. I got to add what? 2 pi. Here's what you should write off to the side. What's 2 pi equal to? Ooh, yes, it's 6 pi over 3. Nice catch. First said 3 pi over 3. That's pi. So what I'm going to do is add 6 pi over 3 to this. It's easier. I had a hard time getting 360 plus 780. I had to add 300, because what's 6 plus 1, everybody? Come on. Did you hear him? This is how my Lexi Samuels is class. 7, Mrs. Krabappel. All right. And then add another 6 pi over 3. What's 6 plus 7, class? 13. Mrs. Krabappel, we love you. And then what's add 6 pi over 3? Oh, I forgot my pi. Whoopsie daisy. And then what's 6 pi over 3 plus 13? Come on, what's 6 plus 13? So you have that off to the side, and then you're able to do this. Now, we're not done yet. We have to take 1/4 of each of these. All right, and then add 6 pi plus 2 pi. What's that? Don't tell me radians are tough, because then you are admitting that you still are supremely fractionally challenged. And I'm going to have Lexi Samuels come and yell at you. 20 pi over 3. Thanks again, Logan, for catching us on that. And then watch how easy this is. It's annoying. You know what's annoying is writing all these answers. But now what do I have to do? Not divide by 4. What's smarter? Times it by 4th. Now stop writing this, because what is every single denominator going to be? 12. I mean, you got blah, 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 fraction, 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 fraction. So my answers are, that's a comma, by the way, pi over 12. By the way, what's 2 pi over 12? Okay, so I will write this one. You should reduce at this point. 2 pi over 12 is pi over 6, and this is going to happen with radians. This one doesn't reduce, so this is 7 pi over 12. That's nice. Fine. I'll write 1/4 here. How many times does 4 go into 8? 2 times. So this is 2 pi over 3. That's fractions 101. So fine, I'll put those in there. This is the only thing that's annoying. You have to answer 4 answers, or I'm sorry, 8 answers. All right, that one's easy. That's 13 pi over 12. Good one to start off with. And then this one is not so nice because it doesn't completely get destroyed. But 14 pi over 12 is 7 pi over 6. By the way, what is 7 pi over 6? I'm just proving that this is before, it's between 0 and 2 pi. What's 7 pi over 6? The what angle measure in what quadrant? 30 or 60? 30 in what quadrant? That's 30 in quadrant 3. This is still smaller than 2 pi. This is why these are answers that work. Yeah. And then 19 pi over 12. And then this is 20. So 1/4 of that, that's 5 pi over 3. By the way, what's 5 pi over 3? The what in what quadrant? The 60 in the 4th quadrant. So it's getting close to being past 2 pi. I'm glad I picked that one to do for us, just because this is the annoying part. It does get a lot of answers. Again, good catch. All right. I guess I do 2 more for the video for those that are at home. What time do we get out of here? So I'm still doing okay that you're not going to have a lot to do when you're done here. Okay, I'm on the degree side now. I'm telling myself that. Is this good or bad as far as making a lot of answers or not a lot? Not a lot. Okay, so that's kind of good when we have an over 2. What do I do first, though, on this? Cosine squared, you square root it. And it does leave the theta over 2 alone. And I guess that's kind of hard. Remember, this means cosine of theta. Don't write this down. This just means this. So for me to square root that just cancels those. I'm trying to just tell you theta over 2 is left intact. Right, when I square root both sides, because mathematically that's what cosine squared means. So I do want you to know that. So this becomes theta over 2, still here, stuck here. Here's the big thing, though. This is plus minus 1. Over, anyone? 1? Where do I get an x coordinate that is either 1 or negative 1 with an r value of 1? 0 and 180. And we are doing degrees. So it's 0 degrees and 180 degrees are valid answers. But now what happens is this is what theta over 2 equals. Because now when you do that, you've freed this. You have done inverse cosine of both sides. That's why theta over 2 is left alone. And that's what I want you to understand. That's the big part of this. By the way, what's 2 times 180? 360. So do I write 360? Yes or no? I'm going to write it, then I'm going to cross it off because I'm going to look at my directions, which I should have done. That parenthesis right there on the directions means I don't write 360 because that's the same as 0. So you just write x equals 0. All right? Not x, I meant, oh, yeah, you're right. It's theta. Don't overdo it that happens all the time. I see that on people's homeworks all the time. Theta, x, variable. One more? Okay, I think I had one more noted, maybe 2. I had 2. Okay, fine. 2 more. What the heck? What do I have to do in number 3 in order to get it ready? By the way, this is radians. Oh, it's a sine 4x again. Let me just get it started and then you finish it. But what do I have to do to get sine by itself? I have to divide. So we had all these on our worksheet before. And then here's what's funny, what happens with this one. You need to rationalize, and then you'll see what kind of thing this is. This becomes 3 root 3. Root 3 times root 3 is a free 3. It's the whole reason you did this. 3 times 2 is 6. Oh, this represents root. Oh my gosh. Hold on. Hold on. This is ridiculous. Is it the exact same as this one? Is it? Then just do this. And then anyone that didn't watch this video or is sitting at home eating bonbons on the couch or whatever, it's the same thing. Why rewrite it all? Am I right or am I wrong? Oh, sorry that happened. I wish I threw that in the degree side. Then you just have to change all your answers to degrees. Go through that process there. I do want to do this one because this is a strange one as well. Oh, no, another tan 4 theta. And it is going to be a little bit rough. So I randomly picked those. Let me see if there's something better. No, that one's too easy. That one's just the same as that. I should do a cosine. Did I do a cosine? Okay, degree side. I guess we have to represent tangent. Okay, first of all, 0 over anyone? 1. Now, could it be plus minus 1? It depends on what these letters are. What's tangent? Y over at, oh. So could that be plus minus 1? Yes or no? Yes. So x could be positive or negative 1. All right. So where do you get, again, where do you get 1 for x, 0 for y, and negative 1 for x, and 0 for y? What quadrants? Where is that? 0 and 180. But this is what 4x equals. So what do we have to do with these answers? Add 360, and then we're going to divide by 4. I could do this one. 360, what you got to have is 4 answers. And you'll see if you go too far. Oh, I got to think about this one. Is that 1080? Whoops, that's wrong. 1080. And then 4x equals 360, 460, 540. 360, is that 900 on the dot? Is that right? Nice. And then 360, that's just 1260, correct? Then I'll show you why. I haven't shown you why this works. I'll just pick any one of these. I'll pick the biggest one as an answer at the end. 0 divided by 4 is still 0. Yay, my pen quit on me. Okay, so x equals 0. 4 into 180, 90. Isn't that 45? And then 360 divided by 4. Oh boy. Oh, 90. That was bad. Sorry. It's theta. I keep doing that. Keep changing x to theta. Thrilling for the movie, right? All right, and then 540 divided by 4. Does anyone got these? I can't. My brain's dead now. Come on, start punching buttons. What's 540 divided by 4? Look at everyone looking around. Aiden's like, I'm not doing it. Who's going to do it? Not me. I'm the good foiler, good factor guy. That's my job in here, right? Yeah, you know your role, man. This is great. Okay, I got it. I'll use brain power on YouTube. Here's Mr. Samuels doing math. What? What? Did someone answer the question? 135? Thank you. And then what's 720? Maybe I could do that one. 1, 6, 12, 18, 20, 5, carry the 1. I don't know. 180? Is it 180? I should be able to do these. I my brain's gone. 4 to 9, 200, 225? I think I got that one. Is it? Well, then let's see if there is a pattern. That's good. 6, 12, 18, 20. I don't know. So add 45. What is that? 270? No. Can I even do that? Is it 270? And then add 45. What is that? 315? Now just let's look at why 315 works, like the one that's way out there. What you would do is type in 315 in the theta spot, and then I got to show you why this actually works. 4 times 315 is 1260. And you don't have to overthink this. What is 1260? It lands in the same spot as 180 just after 3 rotations. So it takes 4 rotations to get in the same spot. So it shouldn't be accessing the same rate, fractions, yes, or the same letters, x, y, and r. In this case, it'd be 0 over -1. But that's the idea why these answers work and why you do what you do. Okay, anywho, I'm going to go stamp away for those that are here, which is many, and that's it.